Aha! Welcome! Thank you so much for coming. So meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users, and we're going to help Hero on their journey. Our job is to help Hero navigate hundreds of CNCF projects, choose which ones to use, integrate them with one another so Hero can live their dream. I'm Whitney, this is Viktor, and together we host a streaming show called You Choose on Viktor's DevOps Toolkit channel. So in our show, each episode is a system design choice, and then we gather all the relevant CNCF technologies that can do that thing. We get experts from each technology, and then we give our experts only 5 minutes to tell us what their technology does. Then at the end of the episode, we ask the community to vote, and whichever technology gets chosen is the one we implement in our ongoing demo. That's it, right? So based on choices you've already made in the show, right now in the demo environment, we have a cluster. It's an AWS EKS cluster defined with cross-plane resources. We also have Argo CD doing GitOps for us, and our application's already deployed. And we have Contour as a way for our end users to be able to access our application. So wait, it sounds like Hero already is in production serving end users. What are we doing here? It's over, we did it. Yeah, good job. No, so the thing is, there's no security in our production cluster, and so Hero's in danger, and so are the users in the system, so we need to save the day. So this is where we need your help. Please get out your phones and scan this QR code, and we're gonna do a live vote today. We're gonna go through 4 system design choices, and then Viktor's gonna build a demo based on what you choose. So we're going to add cluster level policies, we're going to do runtime policies, we're going to manage secrets, and we're going to secure pod-to-pod communication. So let's do this thing. I love how Viktor hasn't said a word yet. This is great. All right, so first up we're going to do admission controller policy or cluster level policy. Our choices are Kyverno, OPA Gatekeeper, and Kube Warden. But first of all, why do we need policy? Well, as things stand, our applications could become bloated and use way too many resources, or they might run outdated versions, or they might pull from untrusted container registries. So we need to add rules to our cluster that will help prevent this and like a bajillion other things that we don't want to happen from happening. So a policy is a rule that defines expectations of actions that are or are not allowed to happen to objects in our system. It's important to know that it's organization specific. So we could do things, for example, like add resource limits, or we could declare which versions we want to use, or we could prevent our container from pulling from untrusted registries, and also a bajillion other things. So how does it work? So when we make a new rule, we commit to, sorry, I lost my train of thought. When we make a new rule, it adds configuration to Kube API in the form of an admission controller webhook. So basically, if you try to make a change to the cluster that falls under the jurisdiction of this rule, it's going to ask for permission from the admission controller. The admission controller is a piece of software that's running, and if it's a validating admission controller, it's going to answer yes or no. If it's a mutating admission controller, it might change something about the resource. Either way, it's going to return a response, and then the Kube API is going to act in accordance with policy. So let's talk about our tools. The first one is Kyverno. Kyverno is an admission controller that's built specifically for Kubernetes. So you can write policy in YAML. Kind of. It's really a Kyverno JSON query language, and it's meant to look and feel like YAML with the idea that people who are working in Kubernetes can reasonably author and they can reason about policy well. There's a ton of other bells and whistles. It's a mature technology, but that's not those aren't differentiators, so I'm going to move on. Next up, we have OPA Gatekeeper. OPA stands for Open Policy Agents. And with OPA Gatekeeper, let's say Open Policy Agents, you can use that with lots of different stuff all over your estate, not just cloud and not just Kubernetes. And OPA gatekeeper, the gatekeeper part pulls OPA into Kubernetes so you can use it in Kubernetes. It has one big benefit and one big drawback, and those two happen to be the same thing. And that thing is Rego. So with OPA gatekeeper, you write your policy in Rego, and then you can use it across your entire system. Your policies are reusable. The drawback is Rego is notoriously difficult to work with. So maybe, just maybe, you don't want to write policy in YAML and you don't want to write policy in Rego. What should you do? Maybe you want to consider kubewarden. With kubewarden, you can write your policy in any language you choose, and then that policy gets compiled into a WASM module. The WASM module is an OCI artifact. You can even write your policy in Rego and put it in a WASM module. If you really want to make your life hard for no reason. And then you can run that WASM module as part of the emission, the kubewarden emission controller. So now's the moment. Which do you choose? Please. Uh-oh.
That's how much people like security.
Oh, this is exciting. So I just want to remind you all that this is not like a popularity contest. It's not a competition. All it is like, what do you want to learn more about? So if there's one you already know, don't vote for that one, you know? It seems like it's a consensus.
Shall we close it?
Yeah, we're going to close it with Caverno. Let's see it.
Okay, now I'm allowed to talk, obviously. Okay, cool. So I'm going to copy some policy that I prepared. I will show you the policy, but I want to copy it mostly because, why? Because it will take a bit of time until Argo CD picks it up. So add commit -m whatever and push, there we go. Now the thing I pushed is here, policies, Caverno, right? Caverno, right? This is a policy I'm going to push. Three or more policies to be more specific. What can we do with the cluster? Sorry, not what we can do with deployments. And this one says, hey, this policy applies to creating and updating resources and applies to the namespace production, and the number of replicas needs to be greater than 2, right? A very simple policy. And then we have another one for databases. Hey, you can create databases, in this case using cross-plane compositions or composite claims. They need to be small, medium, or large. And if you try to create databases specifically in production, then they need to be medium or large, cannot be small, right? It's very simple policies, nothing special, just to demonstrate how all that works. Now, while I was talking, hopefully, Argo CD cluster policies, Argo CD probably, yes. Argo CD picked it up from Git, deployed it to my management cluster, and you can see that here I have those 3 policies that I explained before. Now, what I'm going to do next is the most important part, and that's that I'm going to copy CNCF demo YTT, which is my application defined as Carvel YTT. And now if you're asking why is Carvel YTT, that's because in the previous talk we had nobody knows when, people chose that one. So I'm copying my application, and I'm going to edit and commit and push. There we go. And now Argo CD will pick it up, and we can watch it. So let's say kubectl get -- namespace production get deployments, for example, right? No, that's the wrong thing. It's not deployment, that's deployments. There we go. Now, let me just make sure that Argo CD picks this up and it creates something. It might work, it might not work. My measurement of success is that if it doesn't fail at the very beginning, what might be happening is that port forwarding Argo CD, let's say, okay, yes, it's getting back up. Will it find out there's my application? Cool, right? So, and this says try again, and then you try it again. Anyways, my application has been deployed, but the important part is that if I do kubectl namespace production get all, you will see, hopefully, that there is a there is a pod, but not from the application. There is a service, there is stateful set, not from the application. The deployment is missing, right? Why it's missing? Because of the policy. Easy. kubectl, let's see what's going on. kubectl, namespace, production. It's very hard to type while this thing is sticking in my eyes. Describe deployment. No, there is no deployment. Yeah, sorry for that. There is no deployment because Caverno prevented it from being created, right? So what I'm going to do next is that I'm going to increase the number of replicas of my application.
You move the prompt to the top of the screen?
Yes, I can.
Thank you.
There we go. Right? Caverno prevented it from running.
That didn't.
And what?
It's still on the bottom.
What's at the bottom?
The prompt. Like people in the back can't.
Ah, that thing. Okay. Okay. You're too demanding. That's just. And there we go. Okay. Is it enough?
Beautiful. We'll
Are you happy now?
Yes, thank you.
By the way, they called her grumpy in the last talk. And this is a proof. Okay, let's fix it. I don't have enough time to chat with Whitney. Vim, I'm going to fix it. YTT, values, prod. I'm going to change something here. What am I going to change? I forgot. Yes. What? Yeah, replicas, exactly. Replicas. No, I forgot what I put it. What did I do?
2, they say.
2. Yeah, but I'm not sure whether that's the value I put. Let's say it's 2, that one, right? And let's say that I might be completely wrong here, but I know I forgot something. Okay, that's fine. That's fine. Maybe it will work, maybe it will not. Git add, there we go, push. And now it will digest it for a while. We can go to the next choice and come back to this later.
Well, I'm on pins and needles.
You want slides now?
Yes, please.
Okay. I'm gonna get your slides. There are your slides. Let me try to move the prompt.
You're inspiring all kinds of confidence.
Yeah.
Runtime policies is what we're talking about next. We're going to talk about Falco and KubeArmor. But first, what are runtime policies? So do you completely trust everything that's running in your cluster? Do you trust the internal applications? Do you trust third-party tools? Do you trust your dependencies? Do you trust every single process that's running in your whole cluster? How do you know if something suspicious is going on? And that's where runtime policy comes in. So with runtime policy, we're looking at what's happening at the kernel level of each host machine. So we're looking at kernel events and looking for suspicious behavior. So we're looking for unknown unknowns at runtime. So with runtime policy, you monitor your application, define your expected behavior, and then you can make a runtime policy that does something when an anomaly is detected. Now, what that something is depends on our technology. So let's jump in. First up, we have Falco. Falco is a cloud-native threat detector. Falco has a few different sources, so you can get kernel events from the kernel module, or you can get it from the eBPF probe, but you can also, there are plugins, so you can pull in like kubectl logs or cloud provider logs, or there are a bunch of them, 13 or maybe. So that's Falco. What happens if an anomaly happens is an alert is triggered. And so that alert is really just a text that has some sort of a priority associated with it. Then that alert you can forward to other, so you can use Falco's Sidekick to forward alerts to compatible destinations. They're like 50 or 60, so like email or Telegram or whatever. And then you can use Falco Talon to do something when an alert occurs. So what that something will happen after the alert, and it might be kill a container or get extra information. And then we have KubeArmor. With KubeArmor, it still does the monitoring, it still does the alerting, but it does attack prevention. So this time, when an attack is attempted, it fails. So it never happens at all. So KubeArmor also uses eBPF to hook in the Linux kernel in a safe and performant way. And then it also uses LSMs, or Linux security modules, which are basically access control to the Linux kernel. And that's the mechanism it uses to prevent attacks. It's a younger project. Falco Talent has graduated. And it's time to vote.
Okay, can I finish my previous section while they're voting?
No, because we want to.
No.
Yeah.
Okay.
Sorry.
Okay.
KubeArmor.
I see that you
Right.
Falco folks are trying hard. It's moving, but not.
And they're not mutually exclusive. Like, I'm pretty sure you can forward KubeArmor alerts to like Falco Sidekick. Just FYI. It's not a competition. Yeah. All right. You're up.
Okay. I'm not going to implement that. I'm going to implement where I was before because I forgot a couple of things. First of all, database size should be medium because the policy said that it must be medium in production. And more important thing that would prevent me from doing anything is that I forgot to convert from YTT, Carvel YTT to pure YAML before putting it to Git. You know what? I'm getting lazy. I'm going to copy it. I have it somewhere. Look at this.
This is a Git repo that you have access to also.
Yeah, there we go. Well, there we go. There we go. Okay. And now I can git push and add and commit and push and whatever order, doesn't matter anymore. There we go. And now if I go back to Argo CD and I refresh it, is it working? Yes, synchronize, refresh. And then Argo CD is stubborn, is still thinking that it needs to do what it was doing before. So I'm going to stop it and then start it again. And there we go. Deployment was created and the database was created. And cool. Now, what was chosen?
KubeArmor.
What was chosen?
KubeArmor.
KubeArmor. Okay. KubeArmor. Let's do it. What first? kubectl. Okay. So what I'm going to do is try to do something I shouldn't be able to do in a container of one of my applications. So I'm going to do kubectl. No, kubectl. / namespace production. I want to exec something, and that something is CNCF demo controller. This is actually Schema Hero now. And the reason why I'm using Schema Hero instead of my application is because my application is based on Scratch image, and there is nothing you can do to it anyways. But I'm going to say, hey, I want to output all the files in this container, right? This should not be allowed because if somebody malicious comes and outputs and they can do stuff to those files, right? This should not have happened. So to fix that, I'm going to say, I'm going to annotate namespace production and say KubeArmor file posture equals block. And overwrite what over. Why don't you correct me? Are you French? You don't know English. Is that the thing? Overwrite. Okay. And now the last thing I need is I'm going to copy the policies for KubeArmor. There we go. KubeArmor and to infrastructure run doesn't matter. Here we go. And I'm going to push it to Git and commit and push, no, add commit push, there we go. And now Argo CD should deploy KubeArmor and I will be able to apply the rules. And you can see what I just, the policy that I just applied. Here it is, that's what I pushed to Git. I'm just saying, hey, this essentially, long story short, this is the only thing you can execute in that container. Anything else, not allowed. Right, the short version of all that. Now, if I say KubeArmor namespace, KubeArmor -- namespace production get KubeArmor policies. There is no policy. There is no policy. There is no policy. Infra. Because Argo CD did not yet infra, I said. There we go. Did not yet pick it up. It will, probably, eventually. Is it there? There we go. There is a policy. No, it's not yet. Wait. Now I'm going to execute the same command before, right? This is from my history. Remember this command that output all the files? That's not the reason to clap. Come on. I don't know what I did wrong. I'm going to probably annotated it bad. Cuba armor file push. That sounds correct. Block. You know what? Imagine that it worked. Let's go on. Imagine that it works. In the real world, it works. When I'm not, when these things are not sticking in my nose, it works.
It's important to know it's Viktor's failing and not KubeArmor's failing, I think.
Exactly.
All right.
Wait.
You want to keep?
Yeah, it still works. It doesn't. Okay. Go for it.
You can think it through while I talk about secrets management.
Yeah.
So for secrets management, we have 3 tools: external secrets operator, secret store CSI driver, and SOPs. So with secrets management, our application and applications like ours have a lot of different confidential information they need to manage. So most of this can be done with a vault. A vault is a technology that basically it stores secrets safely and it has an API to access it. That's the bare minimum. A vault with itself is probably also doing secrets rotation and helping with remediation. But the vault is not what we're talking about. What we're concerned with, how do we get our secrets into Kubernetes? So first we're going to talk about how external secrets operator does that. So what it does is it connects to the Vault API, it gets the secret, and then it writes that secret, it makes it a Kubernetes secret, and it also manages the lifecycle of the Kubernetes secret. Then our application can get it, and our application has its secret. Now, external secrets operator has 2 rad alpha features. For one, it can take Kubernetes secrets and it can push them to the vault, and it can also generate Kubernetes secrets. Next up, we have Secret Store CSI driver. As you can maybe guess from the name, it uses CSI, or container storage interface. The idea here is they think that Kubernetes secrets aren't very safe. They're basically just base 64 encoded and stored in etcd. So they want to make a secret solution that doesn't use Kubernetes secrets. So what Secret Store CSI driver, the first thing it'll do is mount a temporary file system to the pod. Then it reaches into the vault and gets the secret and writes the secret to that volume. And then our application can access the secret as part of its file system. And then the next one is SOPs. This is short for secrets operations, but if you call it secrets operations, no one will know what you're talking about. With SOPs, all it is it's a CLI that can encrypt and decrypt files. So here we are defining our Kubernetes secrets, and we can use the SOP CLI to encrypt the secret parts. And then there's also a decryption key associated with it. So how that works in our workflow is our vault is now storing the decryption key. It's not storing our secret anymore. So because that is encrypted, we can commit it to Git. So we commit it to Git, Argo CD picks up the change, and then Argo CD sees it has an encrypted file. Now, we have to teach Argo CD what to do, so we use a configuration management plugin, and then it will pull up the SOP CLI, which gets the decryption key and can decrypt the file. Then that can be applied to Kube API, we have a Kubernetes secret, or we can access it, and and that's SOPs. So now you get to vote, please. Oh, interesting. It got really quiet in here.
They're all concentrated on voting.
All right, it seems pretty definitive. Secret Store CSI driver is what they've chosen.
SSCSID. Cool. Okay. I'm not going to do it. And the reason is very simple. It's actually great, but it works only with your applications, and I'm planning to put a secret for my database that is used by Crossplane, and any third-party application expects secrets, so volumes will not work, right? Great project, doesn't work for me today. So I'm going to choose myself what I'm going to use then, and I'm going to use external secrets. This is the first time I'm doing that, meaning that I am pro-choice, but not today. If I take a look at the secret CNCF demo DB password, right, and output it to YAML, and this is the secret I already have in my cluster, right? And you can see the password, and if I output that password, then base64 decode it, you can see that, what is wrong? What did I do wrong? Equal in the end. Ah, okay, cool. There we go. That's my password. Now the problem with this password is that it is hard-coded in a manifest that I applied before I started this talk. This is unacceptable because if you go to my GitHub repository, you will find out what the password is. We shouldn't be doing that. So instead, what I have is this. I'm going to go to my application, and here, there we go. This is my application right now, and somewhere there is that secret. There is this secret, right? Unacceptable, anybody can see it. So what I'm going to do is open that, you know, the values pro that I used before unsuccessfully. And I'm going to say that my database should not be insecure. This is false. And I'm going to execute YTT again to generate the manifests, which probably this time might work. Who knows? There we go. And I'm going to push it and commit and push it and do all the things. And now, if I do kubectl --namespace production get external secrets dot external secrets.io. It's probably not yet there, but I will refresh my application in Argo CD. Up, there we go. And this one, come on. And now, if I, there we go. There's external secret. Right now, what this did is that this now went to my external secret, to secret manager in AWS, and retrieved the secret for me. And if I do get secrets, you will see that there is a secret, my DB password, and if I output that just as before, and this time remember to copy the everything. There we go. Echo -n. This is the secret from my secret manager. It worked this time. 2 out of 3. Let's go, Whitney.
Let's do it. One more. So next, we're going to secure our pod-to-pod communication. Our choices for this are Istio, Linkerd, and Cilium. So there are 3 aspects we need to concern ourselves with to secure pod-to-pod communication. The first one is identity. We need each of our pods to have identity, and we need them to be able to verify each other's identity. The second one is encryption. We need to encrypt the connections between the pods. And then finally, we need policy. So pods that shouldn't be able to talk to one another shouldn't be able to talk to one another. Don't let them. And Istio and Linkerd both do this in a similar way, in a service mesh way. So here's our cluster. It's flattened, so I can illustrate how this works. So basically, Istio and Linkerd, they inject an extra container into every pod that's running. And then Istio or Linkerd can act, and then those containers act as a proxy for all the requests going to and from the pod. So then Istio or Linkerd acts as a control plane that a human could use with lots of custom resources to do the complex work of configuring how all those proxies talk to one another. So that's called the data plane, is all the proxies. So what differentiates, oh, let's talk about how it relates to our three things. So Istio and Linkerd use MTLS, which does the identity and the encryption all in one step with certificates. So it's using digital certificates and X509 certificates. And then you can use policies that you create with the tools to restrict access between pods. So Istio and Linkerd. Istio uses Envoy as the data plane, which is very powerful and very complex. And that Istio is a super full-featured tool. If you can do it with Service Mesh, you can do it with Istio. And Linkerd can do most things, almost all of the things, but really it focuses on operational simplicity and performance. So Linkerd uses a custom-written Rust proxy as its data plane, and the Linkerd people will tell you that this proxy uses only 10% of the resources of the Envoy data plane that Istio uses. But if you ask the Istio people, they'll say, that used to be true a few years ago maybe, but these days it's about the same. I don't know who to believe, so I'm just presenting both sides. Then we have Cilium. Cilium, this is a whole different beast. So Cilium is a CNI implementation. CNI stands for Container Networking Interface. So CNI is a specification for how a kubelet gives an IP address to a new pod that it's creating. So kubelet and Cilium might have a conversation like, hey, can I have an IP address, please? And Cilium would be like, yeah, totally. Here's your networking stack with an IP address. And like, thank you so much. And then Cilium's like, also, I've given the pod an identity using Spiffy. And kubelet's like, I don't know why you're telling me this. It doesn't have anything to do with me. And Cilium's like, also, I have this eBPF program that I'm running at the kernel level in the pod network namespace. And kubelet's like, seriously? And then kubelet's like, also, this pod generates events for everything that the pod does. So this eBPF program generates events for everything the pod does. And the kubelet's like, I think I hear Kube API calling me. I gotta go. And so here we are, Cilium. How does it work with the three things that make pod-to-pod communication secure? So first of all, we already talked about identity. It does that with Spiffy, and that also secures connections between pods. It does encryption. You can do that with either Wireshark or IPsec. So now these two things are decoupled. In our other use case, they're together. IPshark, or Wireshark and IPsec. Yes. And then it also, you can configure it to restrict access between pods. So the thing about Cilium is, as a CNI, a cluster cannot operate unless it has a CNI. So we must already have a CNI running in our cluster. And if it's not Cilium, it's not something you can just like switch out. Like you'd probably have to take down your cluster and rebuild it. So, Viktor, do we have Cilium running already?
Yeah, it's the default anyway.
It's the default. So there's not really any competition for Cilium. You might not have it as your CNI if you just went with your cloud provider defaults, if you're using a managed cluster. But if you put any thought into it at all, you'll almost certainly have Cilium running. So our choices are Istio, Linkerd, and Cilium, which is already running.
But I can put Linkerd or Istio on top of it, so don't worry about that. Yes.
Yes. And there are reasons to. Cilium is great for the three things we talk about, but in terms of all of the features that Istio and Linkerd can do, it's not there yet.
I think that's it.
All right, that's it.
I think that's Cilium. Okay. So, there we go. There we go. I'm going to execute a quick script that will help me set up a couple of things that are just boring to do manually. Cilium sh, and it will install. Actually, Cilium is already installed, but what I did not install in advance is Spiffy, right, which gives identity to my stuff, and that will probably happen soon. Whitney, tell them a joke while we're waiting.
Why did the man fall down the well? Because he couldn't see that well.
Can you do a funny joke for a change?
Why did the monkey fall out of the tree? Because it was dead.
Okay. No more jokes for me. No more. Okay. Installation of Cilium is going.
Do you want to open another tab and try to troubleshoot KubeCon?
No, it doesn't happen. Maybe, let me see. KubeCon, well, source. Well, there we go.
So we do have a repo that we'll have a QR code for later, but if you don't like the choices that your peers have made today, you can go to our repo and you can explore how other choices might work together. Also, you can do it from the very beginning of the story. So we've been doing this for over a year, so we've gone through quite a lot of system design choices at this point.
Okay. There we go. It started. Actually, it takes a bit of time because if you install Spiffy later, some things needs to be restarted and what's not, right? Anyways, so if I do kubectl namespaces production get Cilium endpoints. What are we doing? Endpoints, yes. There we go. You can see that in my production cluster, the pods that were already running there got their own endpoints, and they should be actually now speaking with the other things in or outside of in the cluster, actually mostly securely. What else? What else did I want to show? No, that's not what I wanted. Yes. Let's take a look at the policy, for example. How much time do we have, Whitney?
The red shirt.
Red shirt, 2 minutes. Okay, very quickly policy. Cilium network policy, there we go. There's one policy over there that says, hey, if you go from this endpoint of the application sleep, only those that are, let me actually see the policy, match label sleep. Yeah, only those that have specific label up for sleep can actually access this specific application, and so on and so forth. We have no time to show you that because I would need to spin up a couple of other applications, but there is identity, secure communication between pods, and policies that you can define.
Hero's more secure than they were before. Will you put the slides back
They're
up?
not more secure, but okay.
We didn't, and not every choice. There are other service meshes we didn't talk about. There are a couple other secret solutions we didn't talk about. We just talked about what we had time for. So here's our hero running in a safer production cluster. There are also lots of security choices we didn't choose. This QR code is a feedback form. Please give us feedback. And then that one is the link to the CNCF demo. And we'll be doing our last episode of You Choose, just a recap, an end-to-end demo. We'll be doing that at booth C1 on Friday morning at 10:30, which is the Tanzu booth.
Don't come, it's going to take 2 hours to go through it all.
So. Come hang out with us for 2 hours.
You must have better things to do. Okay, that's no time for overtime limit. Yes. We are getting kicked out.
Yeah.
No time for questions.
We'll be around. I'll have You Choose stickers, so please do stop me and get one. Thank you so much, y'all. Appreciate you.